Hello class, today what we're going to talk about are common ratios and recursive rules. This is still looking at exponential functions. So first what we want to do is look at these two tables and figure out what type of function each table would be represented by. Is it quadratic? Is it cubic? Is it linear? Is it exponential, logarithmic? What is it? Because we've talked about a lot of different kinds of functions so far. So what we're going to do, first you notice your x values, evenly spaced. X values go up by ones, so what we're going to look for is a pattern in the y values. All right. And looking at this, 1 to 2, 2 to 4, 4 to 8, we can see pretty quickly that these are all being doubled. All right. So we're multiplying by 2 each time to get to the next number. So we've got a pattern here. And since it's multiplying, what we have is a common ratio. All right. Common ratio of 2. And so it's times 2, times 2, times 2, times 2, times 2. Where this is a repeated multiplication, and if you remember, repeated multiplication is actually the definition of an exponent. And so what this is an exponential function. So anytime you have a repeated multiplication here, this is a common ratio, then you're going to have an exponential function. If you don't have a common ratio, then it's not an exponential function. That's something else. Right? So let's take a look at B. Again, notice your x's, your inputs, are evenly spaced. Now, they're not going up by 1 like they were in problem A, but they're going up by 2. Up 2, up 2, up 2, up 2, 2. So they're still evenly spaced, so we want to find a pattern in the y's. Well, this common ratio is pretty easy to find. Let's see, do we have a common ratio? Well, 2 times 4 is 8, and 8 times 4 is not 18. Right? 0 times 4 is not 2. 0 times nothing is 2. You can't do it. Right? So we don't have a common ratio on problem B. So what we're going to look for instead are the finite differences. And we've done this before. This is where you subtract the second number, or the first number from the second number. Right? So 0 minus 2, 2 minus 0, 8 minus 2, and so on. And the first differences don't work. So we do it again, and we see the second differences do. They all come out to 4. So sure enough, this is a polynomial function. We've done things like this before, where the degree of the polynomial is determined by which row of differences we're on. Since this was the second row of differences where they all came out the same, this is a second degree function, which we call quadratic. All right. If it had been the third row, it would have been cubic, third degree function. All right. But we've already talked about that, so that's refresher. All right. So not too bad. If you have a common ratio, because you multiply by the same thing every time, exponential. If you have a common difference, first difference, second difference, third difference, it's going to be some polynomial, linear, quadratic, cubic, quartic, quintic, whatever it is. All right. Easiest one to check is the ratio, because if you try doing this with a finite differences, you start looking straight for the polynomials, you go 3 or 4 rows down before you realize this isn't going to work, and you just wasted all this time. Whereas over here, you saw how long it took me to check to see is this a common ratio. Let's see, 2 times 4, 8 times 4, nope, doesn't work, not a common ratio. Whereas common differences, for that, you could go quite a ways before you finally give up and say this doesn't work. So check the ratios first, that'll save you a lot of time. All right? And speaking of which, I would like you to work these two out. Not trying to solve for the equation, we just want to know what kind of equation is it. All right, so pause the video, work these two out, then come back and check your answer. All right, let's see how you did. So number 1, you should have said this is linear. Explain your reasoning. The first differences are constant. Number 2, you should have said this is exponential because they have a common ratio. All right, so number 1, you'll notice these first differences, 15 minus 3, 12 minus 3, 9 minus 3 to get 6. All right, so we have a common difference, and it was the first difference, so it's a first degree function, which is linear. Number 2, now a lot of you might not have gotten a common ratio of 1/3. A lot of you said 3 probably if you missed it. All right? But the thing is, 27 times 3 is not 9. It has to go in this direction from the least x value to the greater x value. 27 times 3 isn't 9. 27 divided by 3 is 9. But we can't divide here either. It has to be multiplication. So what can you multiply by that's the same thing as dividing by 3? And that is 1/3. Right? Division is the same thing as multiplying by the reciprocal. So the reciprocal of 3 is 1/3. And that's why it's a common ratio of 1/3, not of 3. Okay, so let's take a look. That's a typo there. That should be a 1. Okay, anyways, that also probably messed people up. Should have had a 1 there, not a 1/3. That's a couple steps down. All right, recursive rules. All right, but recursive, what does that mean? What about recurring, right? If we say that something is recurring, that means it happens over and over and over and over. Well, if you notice here, we're multiplying by 1/3 over and over and over. On this one here, we multiplied by 2 over and over and over and over. And so what we're going to do is we're going to have a recursive rule showing what is it that we're multiplying by over and over and over. And this is really just another way of writing our exponential function. Right? We're used to having it as f of x equals a times b to the x. If we write it in a recursive rule, what we have is f of 0 equals a, where f of n equals r times f of n minus 1. Okay, that's a lot there, right? And a can't be 0, r is the common ratio, n is a natural number. This is really more looking at it as a pattern, right? This r, this is the common ratio. This says you're going to multiply by this number over and over and over again, right? And what this means, we have f of n and f of n minus 1. This is saying if you're looking for the 9th term in this sequence here, you're going to take n minus 1, so 8. You can take the 8th term and multiply by whatever that ratio is. Okay, so like in that first one we had b times 2. Going to multiply by 2. If you want to know what the 5th term is, so n would be 5. You take the 4th term times 2, that'll give you the 5th term. Now you do need to know where you're starting, right? Because if you're looking for the 5th term starting at 5 or the 5th term starting at 0, you're going to have different answers, right? So that's where this f of 0 comes in. This is basically your starting point, which is a. And if you remember up here, we had said that the a value in your exponential function is the initial value. So this is the starting point. This is the starting point. It's the same thing, all right? B is the common ratio. It's repeated multiplication. Right? It's raised to an exponent, so it's that repeated multiplication. What is it you're multiplying by over and over and over again? Well, that's the r. So if you have it in the exponential form here, you can rewrite it into a recursive form just by moving your a and putting your b in there as the r. Now, all the other stuff, this f of 0, f of n, f to the n minus 1, that never changes. That is always going to be f of 0, f of n minus 1. All right. So let's take a look at this, see how this works. I have this one here. You got a data table. We're going to kind of combine both of this together. We want to write this in a recursive form. So a, what is a? That's where does it start? Well, where f is f of 0. So where does x equal 0, we want to know what's the y value, right? And so a is this 0.025. That's our a value. What's our r value? That would be the common ratio. And if we look up here, let's see, 0.25 times what equals 1? 1 times 4 is 4, though, right? 4 times 4 is 16, and yeah, 1/4 times 1 is 1/4 times 4 is 1. So our common ratio is 4, right? So what's our equation? We take the a, we take the r, and we plug them in. There it is. All right. So f of 0 is 0.25, and f of n equals 4 times f of n minus 1. Notice the stuff in blue here, this f equals f of whatever, that stays the same. Now, how can I take this and write it as an exponential function? Well, very simple. You know, it's f of x equals a times b to the x. Well, a is still a, right? B, as we said, is our common ratio. And so all we do is we plug in a, 0.25, times b, which is 4, raised to the x. That's pretty simple. All right. Let's take a look at this. Here we're not using a data table, we just have an exponential function. We want the recursive rule for it. So here's our f of x equals a times b to the x. It's 42 times 6 to the x. We want it in this format right here. So we need to know what is a, what is r. Well, A is the 42, R is the 6. So to write this in a recursive rule, all it is, where did my recursive rule go? It has vanished. Lovely. There it is. Alright. There we go. So you see, we have f of 0 equals 42, and f of n equals 6 times f of n minus 1. Not too bad. Alright. I want you to write the recursive rules for these two functions here. Pause the video, write down your rules, then come back and check your answers. Okay, here we go. Let's see here. Number 7. Where did it go? Here they are. Number 7, you should have had f of 0 equals 4, where f of n equals 7 times f of n minus 1. And for 8, you should have had f of 0 equals 9. If I put that comma in there, f of n equals 1/3 times f of n minus 1. And again, all that is, you take the A, put it there, B, put it there. A here, B there. That's all it is. So this was pretty simple. I hope you found it useful, and I will see you next time.